In a battery, these are called as terminals of a battery, okay, where the electrodes are placed. If you have ever seen a physical battery, then you will see that there are terminals on which we put those clips. Okay, so these are the terminals of the battery where the electrodes are placed. And at one point, you will place one clip, another clip over here. Then this battery will be connected with the circuit or whatever, wherever you want to connect it. Okay, now this whole battery system has one more resistor also, which is called as internal resistance of the battery. Okay, so this potential across the terminal of a battery, ignoring this internal resistance, is called as EMF. So EMF by definition is the potential difference across the terminals or electrodes of a battery. In a market, when you will go to buy 10-volt battery, so that 10 volt will be the EMF of that battery. It will never be able to supply the same 10 volt because of this internal resistance, but EMF of the battery will be 10 volt. So EMF is voltage of a battery. It is a specific term which is used only for a battery. The same thing if we are going to use for any other two terminals or any other circuit element, we call that thing as potential difference. So potential difference, we can write V is potential difference across any two terminals of a circuit element. Circuit element can be anything. Till now you have just seen resistor, but there can be inductor also, there can be capacitor also. All these things will be there in grade 12. Okay, so difference between EMF and potential difference is broadly this, that when we talk about the potential difference across the electrodes of a battery, we call it as EMF. Now, what is the overall supply by the battery? Battery can never supply EMF. Battery will be able to supply the voltage, which will be including this R. So that's why the net voltage supplied by the battery will be E minus IR. Net voltage supplied by the battery. So I can say that potential difference across the battery will be E minus IR. Mostly in many numerical problems, we assume that internal resistance of a battery is negligible. That's why it is often misunderstood that EMF and potential difference are same. But when we say a potential difference across the battery, it will always be something less than EMF. So if you want to learn it as a formula, this is a better version. From here, let's say potential difference V across the circuit. Like this battery will supply V as a potential difference. So it will go in other circuit elements and it will have the same potential. So this V is replaced by IR if your another circuit element is R. And that is why we have got EMF is equal to IR plus IR. So for that, I'll show you the circuit one more time. We have one resistor. This is EMF of a battery. This is internal resistance. This is the whole battery setup. And this battery setup is supplying voltage V. Now this V supply will be given to the resistor also because that is the net effective supply of a battery. If we go with Ohm's law in the resistor, we can say that it will be equal to V is equal to IR because the net current is I in the whole circuit. So V is equal to IR is the potential difference across resistor. If we go up for the battery, we'll write V is equal to E minus IR, where this E is the EMF of a battery. So from here, EMF will be equal to V plus IR. And if I replace V with IR, then I will finally get I common, R plus R as the formula for EMF. Though it is a formula for EMF, but this is not preferred. You should be able to understand this well. So if the circuit elements will change, then the value of this V will change. But E minus IR remains the same. E minus IR is specific to the battery. Okay. But the value is specific to this circuit only, which is having only one element, which is R. In fact, instead of R, if you place two resistors in series or parallel, the value of V will change. And then accordingly, this formula will change. So that's why this formula, you need not learn. Just understand the process and then possibly you will be able to solve the questions.
Yeah.
So EMF versus potential difference, the difference in the potential of two electrodes of a battery, difference in potential between any 2 points on the circuit. So potential difference is more like a very general explanation, and this is very specific thing. When we are talking only about battery, we call it as EMF. Okay. EMF is always greater than the potential difference between any 2 points in a circuit because EMF is the original voltage of a battery. And then when battery supplies the voltage in the circuit, it will be lesser because of that internal resistance. Okay. So that can be seen in the formula itself. E is equal to IR plus R. Just imagine this R is not there. Then EMF will be same as the potential difference supplied in the battery. But right now,
Yeah.
the potential difference supplied in the battery will be IR, and the potential difference across the battery will be IR plus R. Potential difference is always less than EMF. The reason we have already discussed.
Yeah. Internal
But
resistance.
this is caused by electrical, gravitational, and magnetic field. Everything which is connected with electricity and magnetism, it has all these things only. Around
Yeah.
us, we have charges. Okay, so charges can be moved with the help of some forces, and forces are created by either electrical, gravitational, or magnetic fields. They all have forces. Okay, gravitational force you have already seen. Electrical and magnetic force you may see in grade 12. The difference is only produced by the electric field. So over here, when we're talking about potential difference, it is only produced by electric field. The main reason for that is we are specifically talking about two terminals. And in two terminals, when we say a potential difference, let's say one terminal is at positive, it is having positive charge, the other one is having negative charge. It is said that when two terminals have opposite charges, then charges will flow. They will attract.
Yeah.
When they will attract, the one at higher potential will automatically flow their charges to the one at lower potential. And this flow of charge is, we can say, power supplied by the battery. Till the time the terminals of the battery come at same level, we can say that battery is supplying the power. Electromotive force is the amount of energy given to each coulomb of charge. Potential difference is the amount of energy utilized by 1 coulomb of charge. So EMF is actually, we can say, the input or the energy which we are giving. And potential difference is finally the output which we can experience. Even if you get a shock, that is because of this potential difference. Electromotive force is independent of circuit's internal resistance. Okay. In circuit, whatever internal resistance are there, it really doesn't matter. It all depends on battery. While when we talk
Okay.
about potential difference of the circuit is dependent on what all elements are there in circuit. I was saying earlier also that this is a general formula and this will be very specific formula IR plus R. If I made two resistors over here, if I just put two resistors, then the formula for E will change because across the circuit potential difference will change. So that is what they are saying. Electromotive force is responsible for transferring energy across the circuit. So electromotive force is the push which is helping to push the electrons in the forward direction. As a result, current is produced. Potential difference between two plates is a measure of energy. So how much it can flow from one point to another, it is just that.
Yeah.
When a circuit is unchanged, the magnitude of electromotive force is always larger than the potential difference. When circuit is completely, it should be charged.
Yeah. I was thinking the same thing.
When circuit is uncharged, then magnitude of EMF is always greater than the potential difference because the battery is having its own potential now. So that is the EMF. But when circuit is
Yeah.
completely charged, then size of potential difference is equal to the circuit's EMF. So then they will become almost equal. Electromotive force is measured by using EMF meter and it is measured by using voltmeter. EMF meter will have only one calibration in that. It will be same as voltmeter. If you go, let's say in a physics lab and check it out, okay, there will be only one calibration done for EMF meter and that calibration will be this formula.